Hey buddies, in this video we're going to be looking into the Euclidean geometry similarity type of questions. So the video is basically broken down to 4 parts. First part where we find the angles, second part it is basically where we look into 7.1, then 7.2 and then 7.3. So it means basically if you feel like you can't watch the whole video, you can basically jump into where you might need help. Alright, so without wasting any further time, we're going to go straight into the question. So the question reads as follows. In the diagram below, AB is the diameter of a circle with center O. SK is a tangent to the circle at C. OS is perpendicular to AB. CA and OS intersect at T. KBOA is a straight line, and let A is equals to X. Alright, so the first thing here that I can see that it is given in the instructions, it is that we are told that AB is a diameter. So I'm going to underline that. So that's the first thing that we need to make sure here to get everything that we're given. And then SK here, it is a tangent, and also I have some perpendicular lines, and of course given that there's an angle that is equals to X. So what I'm going to do is, in my diagram, I'll first put in X there so that I know that this is something that I'm given. Okay, so now first part of the video is to basically find the angles, because we can see that here, in order for us to answer this, we need to have all our angles. So the method to do this, it is going to be basically using DRCPT. So with DRCPT, we know that D stands for diameter, R radius, C cyclic quad, P parallel lines, and T tangent, right? So looking into the diagram, I can already see that I don't have a cyclic quad, so I will scratch that, and also I don't have parallel lines. So I'm expecting these 3 parts. So now firstly, we're going to start with the diameter. So looking into a diameter, what are we expecting from a diameter? Of course, theorem that says angle subtended by or angle on semicircle, right? Angle on a semicircle. So what would that angle be? So here, this is our diameter AB. You can see that the angle subtended by the diameter is C2 plus C3. So basically this means that the sum of C2 plus C3 is equals to 90. All right, and then now from here, which means we're done with diameter, and we're gonna go to the radius. So with the radius, when we're talking about the radius, we're expecting 2 things. Number 1, we're expecting angle at center is 2 times angle at circumference, right? So let's go ahead and talk about that one. So angle at center is twice angle at circumference. So the angle at center will be O3 in this case, right? So O3, now O3 will be twice angle A. So I'm just gonna give it a name and then put the X there, because I know that A is X. Okay, so I'm gonna put it 2X. And the second one, I can see that I have O1 plus O2, which is twice B1. So O1 plus O2, it is twice B1, right? So I'm gonna keep that one at that. Okay, and then from there, we're going to look into the second part about the radius. So the second part about the radius, it is base angles of an isosceles triangle. So base angles of isosceles triangle. So where do we basically get this? So this is basically where we're saying that we have 2 radii, right? But then now there's a chord joining them, making this triangle an isosceles triangle. So this basically means now here, this angle is the same as that angle, right? So say C3, right, which is also A is X, right? And then also another part that I see there, which is also part of these X's, it is this triangle, which is the one with OC and OB, right? So basically C2 and B1, they are also equals to X. So I'll say C2 is the same as C3, which is also X. And then from there, I can say B1 is the same as C2, which is also X. So this will help me basically to understand what is going to happen here. So what I'm going to do here, I'm going to put X's there, like that, right? Notice that I'm using a different color, meaning that I'm the one who calculated those ones. Okay, so let's see. Remember here we said O1 plus O2 was 2B1, but now I know what B1 is, so I'm just going to write it as 2x. Okay, from there we're done with that, so we're going to go to tangent. So with the tangent, of course, we can see that we have KBS, sorry, KS or SK as a tangent. So which means number one, we have our radius there, perpendicular to the tangent. So that will then be C1 plus C2 is 90, and also C2 plus, sorry, C3 plus C4 is also 90. Okay, so another one that we basically see there, it is our 10 chord. So the second part, it is the 10 chord theorem. Okay, so what do we see on the 10 chord theorem? We see that C1 is equals to A. So I'll say C1 is A, which means it is X, and then C4 it is B1, C4 it is B1, all right, which is also X. Now I'll only put in X's because I feel like they might be very helpful for me, and also they can fit into the diagram like that. Okay, so what else that we were given here? So we were also told that we have OS being perpendicular to AB. So I'm going to write it here, OS perpendicular to AB. So what does that mean? So basically that means that if OS perpendicular to AB, and therefore O1 is 90 and O2 plus O3 is 90. So this means O1 is 90 and O2 plus O3 is equals to 90. So we're done with the first part, which means we have found all the angles. So let's go ahead and go to the second part where we answer the questions. So the second part here, we're going to answer 7.1. So here they're saying that we need to prove that KCT is equals to T2. All right. So now here they want us to find to prove that KCT equals to T2. Now in Euclidean geometry, the first thing that you always need to do is you need to look where is KCT. So KCT here, as I can see here, it is this angle, right? Now already here you can see that there's a problem here, or there's something that they did to confuse you, right? What is that? So basically what happened is that they've given you an angle, knowing very well that it is broken down into three parts, right? So whenever you have an angle that you can write into three parts, it's always advisable that you write it as according to those parts. For example, here KCT, it is the same as C1 plus C2 plus C3. Now here this is equals to T2. Now basically they want us to prove that this C1 plus C2 plus C3 is the same as T2. Now how do you basically prove this? Very simple. So this is what we do. We first look at in our instruction that we given and see if we can find the value for C1 plus C2 plus C3, right? So now we're going to go back here. So going back here, we can see that from the instructions or from the information that we got there, we can see that we do have what C1 plus C2 is, right? So we know the actual value for C1 plus C2, and not only that, we know the actual value for C3. So which means here we can calculate what is C1 plus C2 plus C3. Now let's go ahead and do that. So therefore, we're going to first say that C1 plus C2, it is 90. And the reason for that, we see that it was radius perpendicular to tangent, right? Now you don't have to worry about this because it is already there, because we've already written it. You're just copying it down now. And then now here after this, we're saying C3 is equals to, we said C3 is equals to A, right, which is X, right? C3 we said it was A equals to X. So I'm gonna say C3 is equals to A, which is equals to X. And then the reason for that is going to be base angles, right, of an isosceles triangle. So now here I need to specify that this is where OC is the same as OA, right? Just to show that we're talking about radii here, right? Now from there we can then see that C1 plus C2 plus C3, it is 90 plus X, right? Now we know the value for C1 plus C2 plus C3. Then now the question that we're going to ask ourselves now is, what is T2? So therefore, to find T2, basically we're gonna go back in our instruction and see if we have T2. Then unfortunately here we do not have T2. So what does that mean when you do not have T2? So basically what this means is that here T2, let me first locate this angle, right? So because if we don't have it, it basically means now this angle can either act as an interior angle, right, of a certain triangle, but then given that we know the other angles in that triangle, and now as you can see here, we only know C3, but we don't know what is O2, so I'm not going to add that. Or it can act as an exterior angle of a triangle where we know both sides, so here we have CO, but we don't know S. Or also again, it can act as an exterior to this side where we have X here and O1. Right now here it says that we don't have O1, but if you remember, we did calculate the value for O1. We said O1 was 90 because OS, we were given that OS is perpendicular to AB. So this then means now in order for us to calculate T2, what we're going to do is we're going to say T2, it is equals to O1 plus A, right? Then the reason for that is going to be the exterior angle of the triangle. Now we're going to specify the triangle so that they don't get confused. So now from here, we can see that O1 is equals to 90. And then the reason was that we were given that OS was perpendicular to AB, right? And therefore T2 is equals to 90 plus X. And then as you can see now here, this angle, it is the same as KCT, because remember C1 plus T2 plus C3, it is KCT, and that is how we get our answer. Now let's go ahead and look into the second one. Second one here, we are being asked to prove that triangle CKB is similar to triangle AKC, which is also similar to triangle COT. Okay, so now here, in order for us to do this, right, in order for us to prove that, very simple, what we're going to do is we need to just prove that the first two triangles are similar to one another and the last two are similar to one another. Because if we can do that, that means those last part are also going to be similar to one another. All right, so now to prove this, what we're going to do then is we're going to look into the first two triangles. Now when you look into the first two triangles, it is very important that you do this. So what is it that we're doing? So basically here, you are told that we want to prove that triangle CKB is similar to triangle AKC. So what we're going to do is you're going to look into triangle CKB. So this is triangle CKB, right? Then you're going to ask yourself that in triangle CKB, angle C here, do we have it as angle C or do we have it as something else? So here, as you can see, angle C there, it is written as C1. So what you're going to do here, you're also going to be writing it the same way. So you're going to say triangle C1. Then for K, you can see it as K, so you're going to write it as K. And then B, you see it as B2, so you're going to write it as B2. So basically, you need to prove that triangle C1KB2 it is similar to triangle. So you're going to do the same thing with AKC. So AKC. So A here, you can see it is A, but then now we have K, right, which is also K. And then we have C, right? So this C, it is C1 plus C2 plus C3. So basically what you're just going to do here, you're going to say 1 plus 2 plus 3. So this then means that we understand that we're talking about C1 plus C2 plus C3 there. All right. Now, after you've written this, before you can even go into your proofs, you always need to first start by looking for a common angle. So a common angle will basically be the same letter that you see on both sides here. If, for example, in this case here, we have K. So K here is going to be our common angle. So which means the first thing that you're going to then say, you're going to say angle K is equals to angle K. So the reason for that, this is going to be your common angle, right? Now, what's the next step? Now, the next step is that what you're going to do now is you're going to basically test that here we can see that you are told already that it is equals to that, right? Why do I say that? Because there is this symbol already there. So basically it means that here they already know that C1 is equals to A, but you just need to come up with a reason why. And also they know that B2 is equals to C1 plus C2 plus C3, right? So we just need to find one reason there. As soon as we find that, then means we're done. So basically here we can then say that C1 is equals to A. So we're going to check that. So if you remember earlier, C1 we said is equals to A, which is X, and that was because of 10 chord. So basically you will then say here that C1 is equals to a, which is equals to x, right? And then let me see if we didn't prove that already. So it hasn't been proved that already. So and then say 10 chord theorem, and then from there, because of we have proven two angles, then this will then mean that b2, you don't have to solve b2 now. b2 will be equals to c1 plus c2 plus c3 automatically, right? And then this will be your third angle. And from here, you can then bring it back to what it was basically, which was CKB, similar to triangle AKC. And then the reason for that, it is going to be angle, angle, angle. All right. Now you know that if you've proven that they are similar, then it means you need to take into account that the ratio is going to be the same. So I'm going to put that so that the next time you're coming back here, we know how to calculate that ratio, right? Okay. So now we've proven the first part. So we're going to look into the second part. So what's the second part? AKC and COT. So now I'm going to say it now. Triangle AKC. Remember AKC was A, K, and C1 plus 2 plus 3. Now this is similar to COT. Now this is where COT is, right? So it means triangle C, it is C3 there, O, it is O2 there, T, it is T2 there. Okay. Now again, they're already saying that this angle is equal to that, so we need to prove the reason why, right? They're already also saying that this is that, we need to find a reason, and also that is because of that. We just need to come up with reasons, right? Okay, so firstly, we don't see any common angle here because they're all different, so which means we're going to skip that one. Then we're going to look at A and C3. So now here previously we did say that C3 and A are equal, so basically we're going to then say A is equal to C3, right? We know that it was x, but then this was proven in 7.1, so I don't need to write the same reason again, right? Then secondly, I'm going to look at K and O2. So K and O2, I just need to see if I have that here. O2, I just have O2 there, so I don't have that. But then now I'm going to check the second part. Even in the 7.1, I don't remember proving K and O2, so which means I'm going to skip those two angles. But then now I'm going to look at C1 plus C2 plus C3 and T2. And by luck, remember C1 plus C2 plus C3, we said it was KCT, and then we said it was equals to T2. So which means now here, I'm going to write it as C1, or I'm going to write it as KCT. I can take it as KCT, that is fine. KCT, or just not to confuse you, let's keep it as C1 plus C2 plus C3, because that's what we got in there. So C1 plus C2 plus C3 is equal to T2. This was also proven, right, in 7.1. And then now, because of we are proving two angles, then basically this means angle K is equals to O2, right, which is the third angle, right? And then therefore triangle AKC is similar to triangle AKC. Okay, so the reason for this is of course angle, 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 right? Now because of we've proven that CKB is similar to AKC, and AKC is similar to, and AKC is similar to COT, I wrote the same thing here, COT, that means they're all similar to one another, right? So conclusion here, triangle CKB is similar to triangle AKC, which is also similar to triangle COT. All right, before I move on, just make sure that you have your heads there like that, you know, this over that, and then that over that. Okay, so now let's go ahead and move into the final part. So the final part, 7.3, they're saying that we need to prove that BK times AK is equals to OT squared times CA squared over CT squared. All right. Now, whenever you dealing with these questions they tend to look tricky, right? But then now there's methods that you need to apply here. The idea here is to basically understand what I'm going to do here, and then this way that I'm going to teach you here is always going to be the same approach, or the first approach that you're going to do when you see something similar to this in your question, right? Okay, So now, first thing that we need to do is that here we need to look into the question that we're given. So here we need to prove that bk times ak is equals to ot squared times ca squared all divided by ct squared. Now the problem here is here. What's the real problem here is that the problem is that here we're given each side being squared, right? So which means the first thing that I need to do here is to basically investigate, right? So I'm going to write it here on the side and I'm going to call it investigation, right? So what am I investigating? So the first investigation that I'm going to do is I'm not going to write anything just now. I'm just going to speak about it. So the first investigation here is I'm seeing squared. So the minute I see squared, I need to think of a theorem, the Pythagorean theorem, where it says that when we have a line drawn from the vertex of the right angle, then that line needs to be perpendicular to a hypotenuse, right? I need to think of that. But then now here, I can see that there is no such thing because here this line cutting there doesn't make this equals to 90 and that 90, right? So basically it means that first investigation is to test if Pythagoras, the Pythagorean theorem, it is here and it is not. So which means that is out. And then now because of it is out, then this means that in part of my investigation, what I'm going to do is I'm going to take this OT squared times CA squared all divided by CT squared, and then I'm going to take out those squares outside. So when I do that, I'll then take it into something like that, right? So by taking it into something like that, what does this mean? So this means now here I have something different here, which is something new here. But that now, it means now here, there was maybe a side that was changed into that. But then now I need to find that side. Now here's the question. How do I then find that side? So what I'm going to do is I'm going to go back into what we had in our similarity because this is where we're getting ratios, right? So in the similarities, we have three triangles there, right? Or three ratios that we can come up with. So first triangle similar to second triangle. So I'm going to write it here. First triangle similar to triangle means that number one, CK, right, over AK is equals to KB over KC, which is also equals to CB over AC. Okay, so now from here, what I did basically, I wrote the ratio of the first two triangles, right? So number one and number two, right? So I'm going to write it as 1 plus 1, sorry, triangle 1 and triangle 2. Okay, so now here, this is what I know about the ratios when it comes to triangle 1 and triangle 2. Now from this part, the first thing that I need to, after having this, what next thing that I need to check here is to make sure that everything that is written here, it is the same as what is written here, right? For example, here I can see that there is BK, but then here I have KB. So it means I need to make sure that I don't write it like that. I keep it as BK because here, if I don't do it like that, it will confuse you. It will confuse me later. So AK is AK, that is fine. OT, there's no OT here. CA is not there. So CA, sorry, it is AC. You see that? I already missed that already. So we just need to make sure that we write everything in order. Okay, so now after I'm done with that, I'm going to look into the second triangle. So the second triangle, it is triangle 2 with triangle 3. So from there, I'm going to write the similarity that I get there. All right, let's see here. You can see that we're having AK, right, over CO. So there's no CO there, so I'm going to write it as CO. So it means this is going to be something new. And then KC, do I have KC here? Yes, I have KC on the second part. There, over OT. OT is there, so that is fine. Equals to AC. I don't have AC, but I have CA. So I'm going to write it as CA over CA over CT. All right, so I have CT there. Okay, and then from there, I'm going to look into the third triangle. So third triangle being first triangle with the third one. So I'm writing down all the ratios because I can see where my investigation is, right? So now from there, first triangle is going to be CK. So just to fix this, just to fix something here, I said CK and KC. So I need to have the same thing here. So I'm just going to fix this into KC. Okay, so here we're looking into triangle 1 and triangle 3 now. So this is CK, so which means I'm going to need to write it as KC over CO. CO equals to KB, which is BK in this case, over OT. So OT is fine, equals to CB. Let me see, CB, I have CB there, so it means it needs to stay as CB over CT. It is also CT there. Okay, then now double check, make sure that everything aligns here, because if there's BK and then now there's KB, it means you're gonna get confused later, right? So just double check and make sure that everything is correct. All right, so now back into the investigation. After you've written all of that, make sure now that the next thing that you're going to do is to then see if you can mark these letters here, right? So now here, for example, we are looking for OT, CA, and CT. Okay, so now taking my pen here, I can see that I do see OT here, OT there, and then what about CA? I do see CA there. Is there another CA? There's also another CA there. And then with CT, I do see CT and CT. Now, out of those things here, I can see that there's a mark here. I can see that here there's the part where it has a lot of marks. So which means this is where we got that OT times CA over CT, because here this OT was cross multiplied and then we're left with KC. Now this then tells me, oh, okay, this is KC, right? This is KC. And the question is this: after knowing that this is KC, the question is that how did KC got squared, right? So which means now I need to ask myself, where did I get KC squared? Then from here, we can then see that, okay, we had KC here and we had KC there, and of course I can't mark that one because I'm already done with that. Now looking to this, I can see, here I can see that when I cross multiply the, right, that's where I get my KC squared. So which means this was cross multiplied, and then probably this is where we got our KC squared, right? Because now not only that, if you're noticing this, we can also even get the BK and AK, right? So what does this mean now? So this means now I do see how we got into my answer. Now to answer it, we then going to say, therefore, first thing that we needed to have here was to basically say KC over AK is equals to BK over KC, right? Then now the reason for this, of course, is going to be prop sides of similar triangles. Then from there, you can see that this is where we're getting KC squared being BK times AK. So I'm just going to write it as BK times AK is equals to KC squared. Okay. Then now from there, what did we do after? After we saw that KC, we had to calculate that. So now from there, we're going to write it as KC over OT equals to CA over CT, and then of course those are the proportional sides of similar triangles. Then from here, this is where we got our KC as OT times CA over CT, and therefore taking it back to BK times AK, which was KC squared, we can then see that this is OT times CA over CT all squared, and therefore your BK times AK equals to OT squared times CA squared all divided by CT squared, and that is how we find our answer, right? Now that's it for this video. Again, very important to understand that in this proof, this means now to conclude, because remember we're investigating here, this means now to conclude, we can then say that if you're given something that you're trying to prove, right, you can see that there's a product there of two sides, but then the answer there, right, looks like that, right? That means your first approach should be this. That's basically all this means. Does this mean now if we're having something like BK, for example, BK, if this we're getting another question which says BK times AK is equals to OT squared, then we need to think the same thing? No, it's not. Why? Because this is not that. Right here, there's these two things that are top multiplying each other, which are both squared, and then there's another one at the bottom, right? So which means now you need to think of it as something different, which is going to have another investigation, right? Which means this is probably something that I'm going to be sharing with you to show you all the type of investigations that you need to understand. So that's it for this video. Please don't forget to subscribe and also hit the notification bell and share this video with your friends. And also please say something on the comment. Just let me know how you think about this video. Did I like it? And basically that will basically help me to know with how it made you feel. And if there's any request, please by all means make sure that you share that with me. And that's it for this video, and I'll see you until the next one. Cheers.